Okay, so I have been getting a lot of students commenting that they are not understanding graphing rational functions, especially when we got to section 8.3. So I kind of put together a chart that shows you, based on which form of the function you're starting with, what your steps are going to be. Now, I had some typos, so if you printed it right away today, then you probably have a bad copy. But if you print it starting now, I have now fixed those typos. So make sure that you've corrected. There's 1, 2, 3 typos. But other than that, if you're starting with just a number divided by x, like 2 over x, the most basic form, you're going to follow this first column. If you have your AHK form, you're going to follow this column. If you have a linear divided by a linear, you're going to follow this column. This is all 8.2. Then we get into 8.3. I'm going to speed through those because this is really where people started having a hard time. Here, these are all going to be a polynomial divided by a polynomial. The difference is the degrees. Remember that the degree, which is our m and n values in this situation, it's the highest exponent. So here, if our m is less than n, then we're going to use this column. And we find the intercepts and we find the asymptotes, and then we can make a table or graph using Desmos or a graphing calculator. Okay. Here, where they're equal to each other, then we're going to find our intercepts, find our asymptotes, and again, table or using Desmos or a graphing calculator. Okay. And then here we have m is greater than n. X-intercepts, y-intercepts the same, vertical asymptotes the same. This is all the same. This is where we've been running into trouble. There are no horizontal asymptotes. So again, we're at the column where m is greater than n. When we have, say, x cubed up top and just an x on the bottom, that's where we're going to have this column. When that happens, when we go down here to our horizontal asymptote, there's no horizontal asymptote, but we can get some other useful information from the equation, and that is that the end behavior is the same as this function, where we take our coefficients and we divide them times x to the, we take our degrees and we subtract them. This is the only scenario where you are having to look at end behavior. So some of you have been looking at end behavior no matter what. This is the scenario where we're going to look at end behavior. Just when m is greater than n, and therefore we have no horizontal asymptotes. Okay, that's the only time you have to worry about end behavior. I'm going to say that like 3 more times. Do not worry about end behavior except where m is greater than n. We only worry about end behavior when m is greater than n. At this point, you don't need to think about end behavior for rational functions except when m is greater than n. Thank you.